comes out of section 8.3, log functions. So to begin with, it's really just a review of log rules that hopefully we have still stored somewhere in our brains, that when you have the log of two things being multiplied, you can write that as a sum of two logs. Now the only difference between what I've just written here and what you would have had on a Math 30 formula sheet is that they wouldn't have used log base e, the natural log. They would have used log base 10 or just log base something else, log base b. But the same is true for the quotient rule, that this can be written as log of m minus log of n. We also know that when we had an exponent inside a log, something like this, ln of x to the r, that exponent can come down front and say r times ln of x. So those rules are there. So it allows us to answer a question like this. Express 1/3 ln y minus 5 ln x plus ln x squared plus 3 minus 3 ln y as a single logarithm. It can only be done because these are all the same base. They're all base e. So the first thing I would do is bring these coefficients in as exponents. So I'd have ln of y to the 1/3 minus ln of x to the 5th. Nothing happens with this next one. And the last one minus ln of y to the 3. It allows me to then write this as a natural log of some big fat operation here. Anything that's positive being added will multiply on top. So y to the 1/3 times x squared plus 3. Anything that's negative ends up multiplied on the bottom. So x to the 5th times y to the 3rd. And that would be a good answer. We have expressed it as a single logarithm. The only thing left to do would be to simplify anything that does. The x's don't, so be careful there. I'll see people occasionally make a mistake with that, but the y's do. If I have y to the 1/3 over y to the 3, if I subtract their exponents, I'll get y to the negative 8 over 3, which would be written best as x squared plus 3 on top, and x to the 5th times y to the 8 over 3 on the bottom. And so that's as simplified as we can get, and because of this plus in the numerator, I can't start looking at canceling anything out with those x's, so we're done. The last log rule that's of particular use to us is called the change of base. Basically says that if you're given some strange, log base 7 of 9, for example, many calculators don't even have a log base 7 on them. In fact, most have log base 10 or natural log, and that's about it. There are some that you can enter in other obscure bases, but even if not, really what we're saying is 7 to the what equals 9. Well, that's not a nice round number, so I'm not going to do that one in my head. But I could say that this is log base 10 of 9 over log base 10 of 7. That's the change of base identity. I can also say just as well that it's ln of 9 over ln of 7, and that's probably where we would go in this course. The answer will be the same. If you punch in ln of 9 and divide that answer by ln of 7, you're going to get 1.129, something like that. Either way, even though these individual log base 10 of 9 is a different number than ln of 9, but the ratio, once you divide them, does give you the same answer. It means that 7 to the power of 1.129 equals 9, as interesting as that may or may not be. So, in other words, if you have log base a of x, you can write that as ln x over ln a in every case. Another interesting log rule, well, maybe let's practice that one more time. If you have log base 5 of 14, you're just going to say ln of 14 over ln of 5, and either leave it that way or express it as a decimal and say natural log of 14 divided by the natural log of 5, and give me an answer of 1.6397, 4, wherever you're asked to round that thing off to. Another interesting little log rule that we didn't really use in Math 30 but can turn up useful is if you have log base a of b, it's the reciprocal answer of log base b of a. Now that seems weird, but let's do it with some numbers that make sense to us. If I have log base 2 of 8, the answer to that is 3, because 2 to the 3 equals 8. Well, if I tried to do log base 8 of 2, the answer to that is, well, 8 to the power of what equals 2? The answer is 1/3, because 8 to the 1/3, in other words, the cube root of 8 equals 2, can be a useful one. It's not on, the Math 30 formula sheet because we didn't run into it then, but it is something that can allow you to simplify things a little bit sometimes.